All right, welcome. Welcome to episode 5 of TGI Kubernetes. This is the 5th installment of me hanging out in our offices here in Seattle, having a beer and playing around with Kubernetes while other people watch me flail. Hopefully, we'll cover some good stuff today. And again, I really want folks to ask some questions. I want this to be as interactive as we can with the sort of time delay that we have with YouTube Live. Today, I have it set up where if folks post comments, it should show up on the right of the screen. And so the big idea here is that I was noticing before we'd have some good interaction with the comments as we were working and talking, but when I posted the videos later, those comments would be lost. And so I wanted to make sure that this stuff actually showed up on the screen. So I'm going to go ahead and get started and test this out to make sure that it works. Testing. Does this show up? And let's see. Boom. There we go. Yes, I can actually see it show up there, and hopefully it'll show up for everybody who's playing along at home. Awesome. So today the topic is, so what I wanted to do, and I didn't have enough time to prepare because, it turns out that startup life is pretty busy. But what I wanted to do was really dig in deep on what it takes to write a controller and actually dig into some code and walk through some code there. But I don't think that that's something that I can wing in an hour. In fact, right now, getting set up with client Go in a Go project is actually a pretty big pain in the butt. And that can take a while in and of itself. So I wanted to do a little bit of groundwork there. And actually that topic I think is meaty enough that I want to turn that into the next blog post for my series on sort of how Kubernetes works at baseline, and actually do that by showing how we can extend stuff. Let's see. So Bob says TGI Kubernetes 4 instead of 5. So this should be 5, but did I say 4 someplace? Oh my goodness, the title is wrong. Okay, so let me go ahead, and I think I didn't change the title correctly. So let me see if I can change that here live. We're going to change it live. Save changes. Does that work? I don't know. We'll see. Yeah, I'm still figuring this stuff out. It's always an adventure. See Kubernetes, I'm just checking out view channel, see what things look like. It's always an adventure with this stuff to actually figure out how things work. Yeah, so this is supposed to be Kubernetes 5. Last episode was 4. And so, yeah, I must have. So yeah, when you're doing YouTube Live, every time you do a new episode, you have to sort of recreate everything from scratch. And so that ends up being a little bit of a pain, and it's pretty error prone. I'm sure there's APIs for that and tools that people have built, but I just haven't had enough time to really dig into it. So with that in mind, let me go ahead and get my view back here so that I'm actually looking at the right thing. Oh no, I don't want to start watching myself because then you'll actually, that's dangerous. No, that's the wrong one. Okay, so yeah. So let's see. So we have some other comments here. So we'd love to see a future episode showing how to get into the development, setting up Go, code, compiling, etc. Yeah, that would actually be really, really cool. I think it'd be a little bit more developer focused, but hopefully we can make it easy enough for folks to get started. And I think there's really two sides to that. There's and I like to talk about what the audiences are, what the users of Kubernetes are. In my mind, there's really two main users of Kubernetes. There's the folks who are creating and operating a cluster, getting the cluster up and running, make sure that it's healthy. And then there's the sort of the application operators, or at least the people wearing the ops hat, who are taking applications, packaging them up, figuring out how they run, making sure that they're running in a healthy way. I actually think that there's a third audience here that's interesting, which is the application developer. And one of the things that we're going to see over time is that with a little bit of integration with Kubernetes, you can do some really interesting and magic things. So what I'd love to do is actually start talking about how to program to Kubernetes from the application developer's point of view versus what does it take to actually start contributing to the Kubernetes system as a whole. Because contributing to the Kubernetes system as a whole, well, I think is great, and we want to see more people contributing. It's a relatively specialized thing, and I think over time we're going to find that the application developer experience is going to be a much bigger thing for folks to actually sink their teeth into. All right, so I still let's see. I want to give me a second here. I'm playing with some stuff off screen on my other monitor here just to make sure that I can actually see I navigated away from the sort of control panel thing here. Yeah, there we go. Okay, live control room. Yes. Okay. So yeah, so with that in mind, I think, let's save that for a future episode. That's something where I definitely want to do a little bit of prep to make sure that I do it justice. And I'd like to pair that with maybe a Git repo where it's like a starter kit of here's some stuff that you can use to get started with doing something that acts as a controller or starts integrating with Kubernetes. But today, the topic that I picked was to dig into all the parameters that go into running a pod. And I think the thing that's really interesting and I think confuses some folks is Readiness Probe versus Liveness Probes versus Readiness Probes versus Liveness Probe versus how things restart and what that whole model looks like. And so let's go ahead and get started with that and see how things go. Again, as I go, if I'm screwing something up, let me know. If there's questions or if something's not clear, also please go ahead and let me know. So with that in mind, let me switch to here. And I have a cluster up and running, kubecontrol get nodes. I did a 4-node cluster this time. This is running on AWS. And it's running using the, wrong window here. It's running using the Heptio quick start. Actually, that's the GitHub project for the thing. Heptio quick start. Yeah, there we go. And so yeah, you can just search for this and there's a link off the YouTube channel. This is easy way to get started, but like a lot of the stuff that I'm going to be going through here would work just as well with Google Container Engine or the really interesting new service from Microsoft, which is the Azure Container Service. What is it? Azure ACI, Container Instances, right? So these are essentially containers without a node in sight, right? So I think maybe we can play with this in a future episode. I have to admit that I'm kind of an Azure noob. Every time I go to the console for Azure, I get really confused. But anyways, so this is an Amazon stack I brought up with 4 nodes, and so that's what we're going to be starting with. And yeah, so let's go ahead and get started. So the first thing I'm going to do here is I'm going to create a pod. And like a lot of folks, there's an easy way to do this, and then there's sort of kind of the right way to do it. And it's kind of confusing. How do you start with one and transition to another? So let me sort of run through some stuff here, and hopefully folks can get an idea of like different ways that you can get started with this. Now, a common thing is that you'll grab a YAML file from someplace else and you'll sort of copy and paste some stuff around. That totally works. But let me show you some other techniques in terms of how you actually can get up and running here. So now I'm going to be starting with a pod, and then we'll work our way up to replica sets. We may not be using deployments this time around because we're not going to be looking at versions and stuff like that. These things are layered on top of each other. Replica sets use pods under the covers, obviously, and then deployments use replica sets under the covers. And so these concepts are all built on each other. I'm going to be doing a little bit more sort of low-level stuff so that we can really control what's going on. So the first thing I'm going to do here is I can do kubecontrol run help. Now kubecontrolRun is a really, really a Swiss Army knife. It'll do a whole bunch of stuff depending on the parameters that you give it. The one that I think is really interesting here, and a lot of folks don't know about this, is let's see if I can find the right parameter here. Sorry, I'm scrolling. You're all probably getting sick watching it. Where is it? Allow image. No, where is it? Generator. Okay, so there's this thing, there's this parameter on CubeControlRun, which is generator. And really what this is this is something that takes all the various command line flags and inputs in CubeControlRun and then produces a YAML out the side. And these are hard coded. There's no sort of real way for users to extend this. But if you actually, let's switch back to Chrome here. If we go and if we look at this help page here, what we'll find is that, okay, yeah, so we got big enough that it went responsive. What we find here is that there's a whole bunch of different generators. One of them is just running a pod. There's running like a replication controller, which is sort of the previous version of a replica set. Deployments. There's jobs and cron jobs. And so run can actually create all these different types of objects depending on the parameters that you give it. And there's this really complex sort of set of like how it actually does the default there based on the version of your cluster. Like if you say I want to do restart equals never, it creates a pod. But if you want to do restart on failure, it creates a job. But restart equals always, which is the default, becomes a deployment. So this is actually, I think, kind of confusing when you're using CubeControlRun. But the other thing that you can do is that you can actually grab these things directly. And if we do CubeControlRun, and can you all see the screen? Is this big enough? Let me know. If I do CubeControlRun generator equals run pod v1 image equals, and I'm going to do gcr.io quar demo quar d amd 64. Okay, so this is kind of a little bit of a mouthful here. Oh, I have to give it a name. So what this will do here is this runs a pod called quard, and you can see it's running. That's great. It's simple enough. I can actually get to it if I do kubecontrol port forward quard D and 8080, and I just know that it happens to be 8080, and then I go to like localhost here. You can see that we get to quard D, and if you guys haven't seen this before, quard D is this little sort of example server that I wrote for this book that's going to be coming out. That I'm an author of, along with Kelsey Hightower and Brendan Burns. And this is essentially a little server that helps you sort of like test out a bunch of the Kubernetes features in a really obvious way. So it's kind of a demo application. So, well, thank you, Antoine, for watching. I really appreciate it. Okay, so we have a pod up and running, and that's great. But what you'll find a lot of times is that while there are a lot of options for CubeControlRun, all the stuff that you want to do is not available via those command line options. The richness of configuring a pod is really difficult to squeeze into sort of the CLI interface. And so CubeControlRun is really a sort of limited view in terms of the sort of richness of what you can do with a pod. Now let's say that you have a pod that's running and you want to start, mucking with it, right, and doing something different. You can move from this sort of imperative sort of like just run a pod type of thing, and you can transition yourself into a declarative mode of doing things. And let me show you how you can go ahead and do that. So I can do kubecontrol get pod quard output YAML, okay? And, oh, what did I spelled it wrong? That would do it. And this actually tells me everything that's going on here for this particular pod, including sort of a really, really big, all sorts of stuff that the system kind of added to the configuration from the get-go. Now I can go ahead and I can output this, and I can save this to a file. And let's see, quard.yaml. Right, and now I can go through and let's see, and I can open up that in my editor here and look at it, and there's a whole bunch of stuff here. There's probably more than I need. But one of the things that you'll see here is this is resource version. So if I took this file and I checked this into Git and then people change it, like you probably don't do this with a pod, but you'll do it with like a replica set and stuff like that. And then I try and redeploy it. After the first time I redeploy it, the server's going to actually barf at me because this resource version essentially says, hey, I'm making a change and here's the base version that I'm building on. And so just taking that API object and then using that as your new base YAML, that's not going to work. So there's actually another option here that we can do. And I'm trying to remember it from memory. Let's see, export. Yes, I did it. So if you do export, -- export, what that does is on the server side, it has everything sort of strip out all the stuff that the server is going to add. So this does a decent job of actually getting this thing up to the point where you can check it in and then sort of like, you know, work with it again. But there's still some stuff on here that we probably want to strip out. Like I don't want my sort of canonical pod definition to be sort of tied to a node. That's something that I want the system to actually fill out for me. And so, so you can use this to essentially take things from the server and pull them back into sort of the declarative world. But it's really, you know, if you're doing anything serious, it's really best if you sort of start from the declarative world from the get-go. So I'm going to do that, but I still like CubeControlRun to sort of get myself up and running. So I can do output YAML, and I can do dry run. So now if I do this, this is essentially the YAML that CubeControlRun is going to actually create and upload to the server. And you can see that this is actually much smaller. And I'm gonna rewrite this to. Oh, it got mad at me. I don't know. Quard .yaml. Okay. So now if I go back here, okay, here we are. We're in a much much simpler thing that we can go ahead and edit. All right, so the first thing let's look at here is this restart policy. So this is actually really interesting. So right now, by default, the restart policy is actually set to always. And what you can see here is kubecontrol get pods. Wide. That's what I want to do. Is you can see that this thing is running. And I believe, if I'm not mistaken, I think I plumbed this in. Did I do? Oh, I didn't do this. I should do this. Let's see if I go through and I thought I had an API that would actually cause the server to actually exit. If not, that's definitely something that I want to add because that's actually something fun to be able to play with. Give me like 3 seconds here. I'm going to actually look at the code here and look at my main. Did I actually have one of these? Sorry. You can tell this is all happening live because I didn't have it all figured out beforehand. No, I don't think I had a quit. Oh, I have to rename these too because this actually isn't the wrong thing. Okay, yeah. All sorts of stuff I got to do here. Okay, I don't think I had actually like. Okay, I'm going to take a note here because I'm going to add some features to Quard. We want to have a quit feature, and then I also have to rename because I moved repositories. Okay, so we don't. Okay, so the ideal thing here would be if I actually went through and was able to tell Quard to actually exit and to exit with a specific exit code so that we could demonstrate some of this stuff. But what we can do instead here is we can actually SSH into one of the node that this thing is running on explicitly, and actually kill it out from under. So there's a SSH command line here. Wait, and I can. This will actually take us to the master, but I actually want to go to this node here that this thing is running on 10.0.19.143. Okay, so I can SSH in there, and if I do a docker ps, what we can see here is that there's a lot here going on because the images are fully resolved. But here's the Quard container that I'm running. And let me actually split my window here. I always have to like figure out how to do this with iTerm because I'm not smart enough to actually remember this stuff. Split vertically with current pro. No, that's not what I want because that actually is to, let's do split horizontally. Yeah, there we go. No, where did it go? Profiles. I'm an idiot. Okay, split horizontally with current profile. Okay, so, and make this a little bit bigger. There we go. Okay, so, and export cube config goals. Cube control, get pod quard. So what this does here, and we'll do, so what this command here did is I'm actually going through and I'm saying, get me the status of the quard pod. -W means I want to watch it, which means that we're actually going to be waiting for the server to tell us if the status updates at all. And then wide says, give me extra information because that's kind of useful. So now I'm actually sitting on this node here that this thing is running on. I can do a PS. And, oh, does it not? All right, so we'll go through, okay, so we can see it running here. So what happens if we actually just kill this container? Docker stop this container, sudo. All right, so what you'll see here is that as I actually went ahead and killed it, the kubelet went through and actually said, oh, this thing went into an error state and now it's running again. So that's kind of cool, right? So if there's some sort of blip, if the thing crashes, if something happens, the kubelet actually tries to get that thing up and running. That's really good. But let's go through and actually do something that's a little bit more spelling mistake. I had a spelling mistake earlier? Oh, the quards, yeah. Okay, but regardless, we can go through. So there we actually did the Docker stop. Here, okay, yeah, so we actually see it there. I'm surprised I didn't see it before. You can see this is running as that. I can do sudo kill that thing, and you'll see the same thing happens, right? That thing killed, and it should restart it. Or is this, I think, oh, this is interesting. Oh, crash loop back off. Okay, and then it actually went ahead and ended up restarting it. So, so it took a little while maybe for Docker to realize that thing, you know, for Kubernetes and Docker, the kubelet and Docker to actually get their act together. But eventually it detected that I killed that process died in some way, and the thing is now back up and running. And you can see that each time you do that, you actually see an increase in the number of restarts here. So this is all happening on the node. If the Kubernetes master like disappeared off the face of the earth, the kubelet is supposed to continue to run, and so all of this sort of like restarting is happening very much local to the kubelet. So the next thing, let's actually really whack this thing, but good. I'm going to actually go here, and hopefully I have enough screen space to be able to do this. And I actually haven't done this before, so this is going to be fun. And I'm going to shrink the font here a little bit. I'm going to go to EC2, and I'm going to kill this node out from under it so I can look at my running instances. This is maybe, why am I not seeing it here? Is this thing confused? What am I doing wrong here? It says 1 to 6 of 6, but then it's actually not showing up. So launch actions, no. I'm in the right zone. I'm seeing these. But do I have a filter on? Strange. Why is this not showing up? Anybody have an idea here? Reduce screen size? Do you think it's the reduce screen size? Maybe no. Yeah. Oh, there it is. Look at that. Oh man. Okay. So this is kind of a little bit of a bug in the the AWS console here. Okay, so so here you can see all my nodes. There's a master node in 4 of these nodes. So now if I go through and I'm going to go ahead and I'm going to kill 10.0.9, blah, blah, blah. Let's see, where is IP4 public? Let's show the column. Let's see, can I show private IP address? Because that's what we can use to actually find this. Private IP address, we want to kill the one that is 19.143. So it's this guy here. So we're going to go through and we're going to instance state terminate. Yes, I really want to do it. And that'll actually delete the EBS volume and all that stuff. So this is like, what if a node just goes ahead and fails? Let's play around with this. So now this is actually more interesting because the kubelet's going to disappear off the face of the earth. This is probably somewhat of a clean shutdown, so there's a good chance the kubelet will actually be able to tell the master, hey, I'm disappearing. But again, I'm flying a little bit without a net here. I actually meant to do this before I did the TGIK, but didn't get a chance to actually do this particular thing. So I'm fairly confident that we're going to end up in a good place here, but let's go ahead and see. So, okay, so this thing is running. Okay, so we got another running here. Okay, terminating. And so we got an event here that something updated and the thing is terminating. And so this is a clean shutdown. And so it's actually letting the rest of the system know that this thing is, and then you can actually see that we got a broken pipe and the thing where I had it logged in got logged out because the machine shut down. Now what you'll notice here is that this pod is dead. And if we look, because we're actually using an auto-scaling group here in Amazon, theoretically, Amazon should launch a replacement instance for this particular node. And so let's see if that actually happens also. Yeah, so the auto-scaling group in Amazon is actually building a replacement there. So Amazon's making sure that even if one of my nodes fails, I still have 4 nodes that are running. If I go back here and I do kubecontrol get nodes, you can actually see that as part of that thing disappearing, it actually shows it disappears from my node list. Different cloud providers actually do different things here, and this is one of the things that the community is working through. What happens if a node disappears from the cloud provider list? Do we actually go through and sort of remove the node object from Kubernetes so Kubernetes forgets about it altogether? Or do we go through and leave the object there? What happens if because some cloud providers have this idea of having an instance that's stopped but not terminated. What does that mean with respect to how things integrate between Kubernetes? And there's really some inconsistencies right now between different clouds. Google, I think, does something, the Google cloud provider does something different from the Amazon cloud provider. And as a community, we're trying to get our act together and actually bring some consistency there, but we also want to make sure that we don't change behavior that folks may be relying on. So what you're going to see here is if this all works, and it did, is that new node that Amazon, the auto-scaling group actually created for me is now up and running, but it has a new identity here. So like we're at 21-4 versus the other one. Now, what you'll notice is also, if I go ahead and if I get my pods, there's no resources found. There's no pods. Well, it's actually, okay, so it actually disappeared, right? So that pod is actually gone. And that's because the node shut down in a clean way, and so that pod is gone. And so the lesson here is that once pods get assigned to a node, they stay on that node. And there's a lot of reasons for that, and I think I might have covered this in a previous episode. Thanks, Alex, for the compliment there. But as once they hit a node, they stay on that node, and we don't try and actually move a pod or reschedule a pod from one node to another if we think that node has failed. Now, in this particular case, we felt like this is a little bit of a clean shutdown of that thing, and so the kubelet was able to actually notify the Kubernetes API server that, hey, I'm shutting down. Things got cleaned up in a clean way. That doesn't always happen in distributed systems. Sometimes things just disappear and you don't know if they're going to be gone for like 30 seconds or if they're going to be gone for like 30 days. And so if they're only going to be gone for a short amount of time. What is the right amount of time when we decide, oh, that pod is dead, let's actually recreate it someplace else? And then what happens if that pod actually that node comes back online, or at least we can see it again and detect it? How do we actually go through and reconcile the fact that now we have the same sort of logical pod running in two different places? That ends up being a real problem, especially when you're doing things like tracing and stuff like that. And so the real answer to that is a replica set. So, so our pod is gone, but let's actually now create a replica set. So what we're going to do here is we're going to actually call this thing a replica set. This thing here becomes, or actually let's do it this way. We're going to do, let's see if I can remember how to do this off the top of my head. So this is you actually seeing me. So we're going to indent this a couple of times, and we're going to template, and then we're going to do API version v1, and we're going to do kind replica set, and then spec, and then we're going to have meta. And most people will copy and paste this. Name quard, and we don't need the name down here. And we're gonna do, yeah, that should be enough. Actually, let's throw this at the wall and see what happens. So CubeControl create -f quard. Okay, error validating. Couldn't find type v1. Oh, is this extension? Am I doing this right? Oh no, versions. Oh man, I'm gonna have to cheat and look it up. I can't do it from memory. You can actually see that even I don't remember this stuff. So I want to work on actually improving this, because like this is way harder than it needs to be able to do this stuff. Extensions v1 beta 1. That's what it was. That was the API version. I didn't get that one right. I accidentally copied instead of pasted there. So now let's see. I'm sure I screwed something else up. Let's see what I do. Okay, error validating, found invalid field, found invalid field API version. Okay, so we actually don't need this stuff here. Field status. Oh, you can't have status in the template. Okay. Oh, it worked. Okay. So now what we have here is CubeControl get pods. Now we actually see is that we have a pod. This thing is no longer called quard. It's actually called quard-QNCZT. And so the replica set creates a unique identity for that pod. If I actually go through and in CubeControl get replica sets, you can do this shortcut here of RS for replica set. We'll do wide again. What we can see here is the name of the replica set is quard. We want one of them. That's our desired count replicas. It's we currently have one, and one of them is ready. 29 seconds, one container, blah, blah, blah. And there's like a selector and stuff there. I won't go into detail there. Now, if we go and look at the pods, CubeControl get pods. All right, so this thing's running on this node. Let's do that game again where we actually kill a node. And this one is, what was it? It was, okay, well, oh, and we'll do this OW, right? So this thing is actually running on 134, okay? So 134. Now, if I were gonna go through an SSH into this machine and actually kill it out from under it, the kubelet would still do its thing. It would actually go through and restart it locally. But now if I actually go through and terminate this instance, and is there a like, I know with GCE there's a way to essentially do a hard terminate, which essentially says don't wait for the node to actually shut down cleanly. But now if we go back here, that node is shutting down in a clean way. This particular pod is going to actually error out or disappear. And what we expect to see here is that the replica set is going to notice, hey, I was supposed to have one of these. I have 0 now. Let me go ahead and recreate a new one. So let's just wait a second here and see how this works. Okay, okay, yeah, oh, it's running. So something changed there. I'm not sure what changed. The tab, or like there's like, I don't know why this thing doesn't line up like that. So a lot of times when you're doing a watch, you'll actually see extra lines because something actually changes behind the scenes. Okay, so what happened here is that this thing was running and then it was terminating, and the Replica Set controller, which is a piece of code that's sitting in the back end, is watching all of the pods that are out there that match the sort of the set of pods that Replica Set is actually running. It notices that one of those is terminating, and it's like, oh, now I've actually gone below my desired number. Let me go ahead and fix it. And so then it goes through and it actually creates a new pod on a different node here. And so it automatically, and a lot of times people will talk about Kubernetes rescheduling pods. In reality, it doesn't reschedule pods. What it does is it actually recreates pods on a different, with a different name to replace the ones that had actually disappeared before. And so you can actually see that this is a new pod here. Okay, so let's do one more thing here. Let's going to go back, and if we look here, we have this restart policy always. I'm going to actually change this to restart policy never. Okay, and now I'm going to go ahead and I'm going to apply that. And if I actually do create here again, it's going to, okay, is it restart policy never? What is the restart? Oh, darn it. See, look at that. Kubernetes restart policy. So we're working at Heptio here on this system called KSonnet that'll have a lot of ways to actually deal with this in a sort of, instead of writing YAML, you're going to write this different type of format. And we have a Visual Studio extension. And so there'll be a lot of things to actually help you remember this stuff while you're in the editor. Restart policy. If we actually look at it, where do we have like so yes, you can do replica set and never, and that, yeah, so that's the interesting thing here. It does actually go together, and I'll explain sort of why. It should be able to support it. Maybe it doesn't. Maybe it actually tells you not to do that, but I've done this before. Always on failure or never. Okay, so the restart policy should be never here. But maybe the replica set doesn't like it. The replica set shouldn't care. Supported values always. Oh man. Man, I wanted to show this. Okay. So actually it should support this. This is relatively new. And or maybe it was the replica controller that could actually do this. What I expected to happen here, if you set restart policy to never, what that means is that the pod itself will never be restarted, but if that pod fails, it'll actually get rescheduled onto another node. So let's see if this is actually replica set restart policy never. I bet you this is actually, because I tried this at one point. So replica controller. Oh yeah, there's a bunch of discussion there. I did this at one point. Darn it, making me look bad here. All right, I disagree. I disagree with this decision here in terms of not being able to actually set restart policy equals never. Okay, so I was going to demo that and I can't because Kubernetes is actually stymieing me. But you know what? Actually, you can do it with a job, and you can have a restart policy with a job, and I think that's where I played with it before, as I was actually experimenting with jobs. All right. Well, okay. So, but what happens here is that there's actually a restart loop that happens on a kubelet, and then there's a restart loop that actually happens from the replica set, the replica set controller, and those things can actually build on top of each other. And so that's what I was trying to actually show there. All right, so let's move on to probes, because I think that's actually some interesting stuff. And actually, let's go ahead and actually change this to a deployment. And we're going to actually go through, and I think it's apps v1, beta 1. Let's kube control delete rs quard. Does that work? Yes. And okay, so and actually what I'm going to do here is we're going to do a CubeControl run image equals this thing YAML dry run. Oh wait, name. Okay, so quard. Okay, so this is essentially sort of the minimal deployment. I'm going to actually write that to quard.yaml here. So here we go. So this is a deployment. It has a spec number of replicas. Let's just do 5 replicas here for fine. Yeah. So Antoine, yes. So we're gonna, KSonnet I think is its own other topic. There's a bunch of really interesting stuff happening with KSonnet. I didn't want to introduce too much stuff by doing KSonnet, which is really new to a lot of folks, while I'm also trying to talk about these other topics. And so KSonnet is coming though, so don't worry about that. It is definitely something that I'm going to be covering in a future TGIK. All right, so here we go, containers, boom, boom, boom. This all looks good. Let's go ahead and do CubeControl apply-f. Okay, so you may be asking yourself, I did apply here. What's the difference between create-f and apply-f? Apply says create it if it's not already there, otherwise do an update. So that's basically what apply says. But there's also some other magic that happens with apply in terms of making sure that if you're using something like horizontal pod autoscaling, HPA, which is kind of like autoscaling groups but for pods, if you're using HPA, then it'll actually go through and not mess with the scale there and actually keeps track of who changed which parameters. So there's some sort of complicated sort of edge cases that apply helps to deal with that is more than just sort of slamming in a new version of the resource of the description. Okay, so here we are. We got this going on. We have 5 of these things running. We should CubeControl get pods. That's what we expect to be seen there. Now what you'll see here, and this is just like a quick primer on deployments, deployments create replica sets create pods. And so this is the name of the replica set, and this is the name of the pod. So you can kind of decode this. You shouldn't rely on it because there's labels for this stuff, but this is how the names actually get created. And this number here is actually a hash of the the description of the replica set. So if I were to go through here and if I change this to 2, and now if I do get pads-w and then I do CubeControl apply-f, what you'll see here is that it kills a bunch of pods and recreates them with the new version. And as it goes ahead and does that, you'll see that the replica set number here changes because the hash of that description actually changed as I did that. So quick reminder of how that stuff works. Okay, so that's all up and running. So let's go through and start playing around with probes. Now I always forget where and how to actually configure probes. I apologize here because Kubernetes probes. And so, oh, not probes, probes. Now there's two different types of probes here. There's liveness probes and there's readiness probes. And I think it's really confusing. I think we tried to actually pick the right name for these. I'm not sure if we went ahead and got them right or not. So liveness probes are, is the thing up and running and it all functional, or is your service wedged, right? And so a lot of times what can happen is that a program can kind of get twisted up so much that it can't even serve simple requests. And so a liveness probe is to detect that case where the program is really in some sort of stuck, messed up situation. Readiness probes is this thing ready to receive traffic? And so you can be alive but not ready, which means maybe you're doing some initialization, or maybe you're trying to shut down cleanly. So those are a couple of sort of, at the beginning of the life cycle and at the end of the life cycle are times when the liveness probe may be yes, it may be okay, but the readiness probe may actually be a failure. And so these are actually two separate things. So we're going to go through and blah, blah, blah. We're going to do an HTTP probe here. And I'm going to copy and paste this. Now this is actually per container. So each container actually has its own probe. And this is the, YAML is great until you have to copy and paste stuff around and then you're like, wait a second, that doesn't look right. And so I think that lines up right. And I think I want this to actually, no, that goes there. Okay. And so I believe I called this thing, if I look, okay, so so what we're going to do here is we're going to go through and pick one of these pods here, port forward. Okay, we're going to port 8080. There we go. That all matches up. That looks great. And we're going to look at this. I have this tab here called Liveness Probe. And so if you hit this, it's /healthy is the thing. If you hit this thing, it actually returns a 200 with OK. And then it actually keeps track of all the liveness probes, and it actually updates in real time in terms of when you saw it and what the status was. And what I can do is I can say, okay, I want to start failing these. Now if I hit this thing, it actually says, oh, I'm doing a permanent fail. That actually returns a 500. If you look at the HTTP code, you can see that it returned a 500. And you can actually do things like, okay, I just want to fail for the next 2 calls. And so if I do, am I healthy? 1 left, boom, 0 left. Okay, now I'm okay. And you can see that this all updates there. I was going backward and forward there pretty fast. But the idea here is that we now have this thing that we can use to be able to detect stuff. So I'm going to go through and actually, so our endpoint here is /healthy on port 8080. We don't need this custom header thing. And the initial delay in seconds is when the container first starts, how long do we actually wait before we do the first probe? Because you may want to give it like 30 seconds to get itself up and running before you start probing it. And then there's how often do I probe it? And there's a couple of other parameters here that are important. Is there like a table someplace of this stuff? I have this stuff. Sorry. Okay, yeah. So here's the thing with probes. We have initial delay seconds, period seconds, timeout seconds. So like when I make a call, how long do I wait for the server to respond before I determine that particular probe is being failed? And then how many probes in a row do I have to see come back okay before I declare that everything's okay? And then how many do I actually wait to, do I see fail in a row before I declare that the thing is actually failed? And so the failure threshold is 3. And so that's the default here. Let's put that there. And then we're going to play with these. And then the success threshold is 1. So if I actually see any successes, I'm going to declare that the thing is a success. So now I'm going to go through and I'm going to go ahead and apply this. What you're going to see here is that that's going to actually restart the pod as we do it. And so I'm going to want to grab one of these new pods and actually do that port forward again. Okay, and so now we're at our new pod here. And the fascinating thing is that now we're actually seeing that we see probes come through. So every 3 seconds, the kubelet is actually hitting the /healthy endpoint of the pod, and we can actually see it on the screen here as we sort of like, as the QRD actually reports the probes that it's seen. So that's actually pretty cool. Now I'm going to leave this running in the background, and I should have okay, so I'm going to add another thing to QRD, which is like collapse the header. So I have a little notebook here where I'm actually, I don't think I'm going to get to it today, but check out my cool document camera. I actually have like a little camera here so that I can actually draw stuff out. But I don't think I'm going to have to use that today. Okay, so we can see it's kind of hard to see a little bit here. Some of the formatting is screwed up, but we can see that we're like returning. Actually, let me do. It's kind of harder to see, but there we go. Okay, so now let's see. Okay, so now I'm gonna run this thing in the background, so that thing is still running, and then I'm going to do a kube control get pod wide. So now I'm watching this particular pod. Okay, let's see what happens with that pod. And now I'm going to actually say, let's fail the next two of these things. Boom, boom. Okay, phew, everything's, wait, okay, so 500s. So we sent two 500s. Okay, and now we sent a 200, everything's good. But remember, we said it that if we actually fail 3 of these probes, then we're going to actually declare that this thing is dead. So let's fail 3 of those probes. 1, 2, 3. Okay, and what we can actually see here is that there's a couple of things that going on here. Is that we saw that this thing actually restarted. So we actually saw a restart. Now this restart happened local to the kubelet, so the kubelet just sort of killed it and restarted it again really fast. The other thing here we see is handling connection for 8080. That's actually the port forward command saying, hey, I needed to reconnect. And then at the same time, we saw the my history of all my probes disappear because we essentially, that's all just stored in memory in QRD. And so when we go ahead and rebooted the thing and restarted that thing, it cleared that memory, that history that we had in here. So, so that's essentially how probes work. Now that's for liveness probes. And so you can do something very simple when you implement a liveness probe where it's just sort of like, it says returns okay. And as it returns okay, you at least know that your server has it enough together that to actually get an HTTP request in and out that actually just says okay. And that's actually really useful in and of itself, because a lot of times where things will get wedged is with the HTTP server itself. Like maybe it has a thread pool where all the threads get locked up, and that's the type of thing that you're looking for. Another thing that you can do is you can instrument your health probe to actually do something a little bit more realistic for your particular application, where it actually maybe does a dummy transaction to make sure that everything's up and working. Now you don't want this to actually hit stuff outside of your server, because your server may be healthy, but something sort of upstream of your server, some other service that your server depends upon, may be sick. You don't want to reflect that as bad for your server, because that may have you killed and restarted when it's not necessary. So whatever you do in that health check, you want to be local to your server and not be impacted by failures for other services that you're depending upon. Okay, so the last thing I want to do here is I want to go through and I want to talk about let's change this from being a liveness probe and let's do a readiness probe. Okay, so Timo says, when would you use a liveness probe versus just relying on the container state being monitored by the kubelet? That's a really good question. So the kubelet will catch if your application crashes. And that's great and that's incredibly useful. But the thing to realize is that oftentimes when servers fail, they don't fail in a clean sort of like I'm just going to crash sort of way. They get wedged. They get sort of like, they fail, but they're still running and they're kind of in a zombie state. And so that sort of zombie state is where the liveness probe really comes in. It actually says, okay, I know that there's a server there. Is it actually alive, right? Or is it, or is it just kind of half dead and not doing any useful work? So that's where the liveness probe really comes in. Okay, let's do a readiness probe here. This thing is upset readiness. Okay, what is it? Duplicate. Oh, we have resource. Okay, we don't need that thing at all anyways. Okay, so so now we have ready. Let's go ahead and actually make that happen. So I'm going to apply this again. This is going to go through and we're actually going to see our watch here. What do we expect to happen? We expect this thing to actually go ahead and terminate. And then you see that our port forward starts complaining because it's like, I can't get to the thing that you're trying to tell me to get to because that pod is gone now. Okay, so So this is great. Now readiness is this thing ready to actually serve traffic? And where that comes into play is with services. And so let's actually go ahead and, oh, let's actually kill this thing too. Get pods. Okay, there we go. Okay, so services are a way for me to address a group of pods in a sort of in a unified way. And so let's go ahead and actually create a service that covers this deployment that I have here. The cheater way to do this is that you can do kubecontrol expose, and then you can point it at your service. And let's see. So expose. What do I want to do? I always forget this too. Okay, so there's port and target port. Okay, deployment expose deployment. And I want to actually say port 80 target port equals 8080. Okay. Then YAML dry run. Oh, it's upset. What is it upset? What did I do? Target port. It's target dash port, isn't it? Yes, it is. I should have known that. Okay, so this is what a sort of simple service is. This is I think like one of the first TGI that I did actually covered some networking. We talked a little bit about services. So you can go ahead and watch the archive there if you want to dig into the different types of services. I'm gonna quard dash service.yaml. We can go ahead and look at that here. I'm not going to modify that, but I just want to show that good hygiene is to actually keep this stuff as YAML files whenever possible. Okay, so Jacob asks, is the pod autoscaler is also bound to the probes? Does it kick in only after the readiness probe turns okay, for example, in order to ignore high CPU utilization during initialization? I don't believe so. There's a whole system for pod autoscaling that actually collects metrics about sort of how much CPU or RAM or other types of metrics about the particular service before it actually starts triggering autoscale events. It turns out that deciding when and how to autoscale is a really hard problem. You want to collect a lot of data. You want to make sure that that data is representative of the of the particular tier that you're looking at autoscaling. Like if you just autoscale when things start getting slow, well, why are they getting slow? Could it be because your particular front end tier is service is actually overloaded, or is it getting slow because your database is overloaded? And if your database is overloaded, upscaling the number of front end services, workers that you have isn't going to solve the problem. And so finding the right metric to autoscale on is actually a really hard problem. Okay, so I don't want to run out of time here. So like here I have the service. I'm going to do kubecontrol apply quard service.yaml. Oh, -f. All right, so now I have that service. Kubecontrol gets service quard. That's exactly what we expected there. It doesn't have an external IP, so this is just an internal service. It's a service of type cluster IP. That's why we see the cluster IP here. We're actually not going to call the service in the example that we're doing here. But what we are going to do is we are going to kubecontrol get pods. So we're going to go ahead and we're actually going to grab one of these pods, kubecontrol port forward to this pod 8080. So we're going to do this whole thing again. So I picked one of the pods that's running here. Let me run that in the background. So that guy's up and running. And now what we can do is I can do kubecontrol get service endpoints quard. And this actually shows me, okay, so it actually, oh, that's not useful. Okay, so if I had more time, I would actually go through and you can select all this. But we can see here that actually lists out the pod endpoints that I'm actually going to. So this is essentially, if I look at the pods, they each have an IP. This is the IP of the pod. And then this is the list of all the IPs for those pods as seen through the service. And so let's go through and actually, I'm going to show those endpoints and I'm going to actually watch them. Okay, so now here we see we have all these endpoints, and this is great. And so now I'm going to go back here, and this thing is okay. So it got restarted. Okay, but now I'm going to actually go to my readiness probe, and I'm going to actually go through and say I'm going to fail readiness on this particular one forever. Now this is 226.70. That is not on this list here. This is one of the 2 mores. But you can actually see that after it failed 3 of the readiness probes, it now is no longer part of the endpoints that the service is actually targeting. And so it got removed from the set of healthy services. And if I actually went through and triggered on each of these things, I could go ahead and do that. But if I start succeeding again, the minute I succeed with one of these things, it actually gets added back to the endpoint pool. And this endpoints API object, this is what all of the sort of load balancing, even if you're using something like Istio, it actually triggers off of all of this. And so this is how a readiness probe works. When the readiness probe starts failing, it doesn't kill the pod because the pod is still healthy, or the container is still healthy. What it does is it just stops sending traffic from it. And the way that it stops sending traffic to it, I mean, not from it to it, and the way it stops sending traffic to it is it removes it from the endpoints for that particular service. Okay. So Dwali Dawal, I'm sorry, I'm probably butchering your name. I apologize. Is saying that the replication controller can be restart policy never, but not the replica set. And you can do it also with jobs. There's a lot of interesting interaction with jobs with this stuff, where you can actually really examine what does it mean to have a job when you're doing different types of exits and error exits and stuff like that, where you do a restart locally versus actually a restart via the server. And I think probably jobs is something that I'm going to have to cover in another episode. Any last questions that folks have before I actually go ahead and sign off? This is the stuff that I wanted to get to, set up sort of how probes work, touch on some of the sort of restart policy stuff and all of that. Parthaban says, Istio queries the endpoint object. Yes. There's a lot of services that talk about how they integrate with Kubernetes service discovery. And what that means specifically is that they actually do query and interact with the endpoints object. That is probably that's why the endpoints object was created, was so that those things could actually integrate there. All right, so Dawal, you know what? I'm not frustrated with it. I think it's probably a reasonable change. If you actually set that restart policy to never, it's going to give you unexpected behavior, because it will logically it'll be restarted, but it'll be a recreate, not a restart. That's a really subtle change. And if somebody says restart, if somebody sees in the YAML manifest restart policy never, they might expect that they're getting a job, when in reality they're not. They should be using a job object. So I can definitely see that there's arguments on both sides there. So no big deal. All right, well, thank you everybody for watching, and please let other folks know, and we'll be doing this again next week. And I just have a lot of fun doing this stuff, so keep sending in more topics, and I'll keep talking and having my afternoon beer and hanging out. See you all later.